This is Mr. Precella, and today in trigonometry we are going to begin discussing right triangle trigonometry. We've already defined the 6 trig functions, sine, cosine, tangent, and the reciprocals in terms of what I refer to as the XYR definition, where XY is a point on the terminal side of the angle theta, and R is that distance. Here, we're going to draw a right triangle. The right triangle has that 90-degree angle. And we're going to call one of those angles in the right triangle, one of the angles theta. Don't call the 90-degree. Call one of the acute angles. Acute angles are the ones less than 90 degrees, if you remember your your geometry. Let's call one of those angles theta. You could either call this one or that one. I'll call this one theta. And just state the definition. Well, in a right triangle, the side opposite the 90-degree angle is called the hypotenuse. The two sides that form the 90-degree angle, they're called legs, and I'm going to refer to each of these legs in reference to the location of theta. The leg that's opposite that angle theta, I'm going to call, opposite. The leg that's adjacent, that means closest to the angle theta, I'll call adjacent. So we have a hypotenuse, that's always opposite the 90-degree angle. And then we have the two legs, which we'll call either opposite or adjacent, depending on the angle, where your angle theta is. If this angle up here had been theta, then opposite wouldn't be right beside it. It would be here. Opposite theta, closest to theta. So I'm going to define the 3 primary functions, sine, cosine, tangent. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. This is consistent with the XYR definition. If we think of the XYR definition, you can always imagine the x-axis, y-axis, theta. The hypotenuse would be what we would call R, and this vertical we were calling y, and the horizontal, that adjacent, is x. So y over r, x over r, y over x. Now for the other 3 trig functions, they're just the reciprocals. Cosecant would be hypotenuse over opposite, secant theta, hypotenuse over adjacent, cotangent, adjacent over opposite. But when we're working with right triangles, these are the 3, usually these are the functions you're going to use rather than the reciprocals. On problem number 1, here's a homework problem. Let's discuss how to remember this. Somehow you need to remember that, and I remember my 11th grade teacher saying, you remember the 11th grade teacher saying, remember the Native American name, SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So you can remember SOHCAHTOA That might help you remember it. I've heard some other things. Some old hippie caught another hippie tripping on acid. That's, sort of funny, but it might not be the best way to remember it, because what I always think is some old hippie saw another hippie. Okay? So caught makes it sound like the police would catch it. So some old hippie caught another hippie. You got to remember that this is where the caught is, so you see cosine, tripping on acid. Another one, Sally can tell. That gets you these three. Tells you how the order go. Old Harry always has old apples. Which way do I think? Sokotoa. Okay, just because that was the first way I ever heard it so many years ago. So if we want to do problem number 1, let me see. Problem 1, can I get it on here? Well, no. What if I do it like this? Okay, up. There. We're given a triangle, and there's numbers here. Sine theta. Well, you got to be sure you're right. There's the hypotenuse. The leg that's opposite. Notice how I draw that angle. This is the opposite. Not because vertical is always opposite. It's opposite the angle theta. So sine theta would be opposite over hypotenuse. Cosine theta, adjacent over hypotenuse. Tangent theta, opposite over adjacent. Now, let's do one where the picture's not drawn for us. This is problem number 4. Oh, it looks long, doesn't it? Okay, it takes up a whole page. Problem 4. Suppose ABC is a right triangle with sides A, B, and C. Well, first of all, that's telling you how we're going to set up these right triangles when we draw them. We're going to have the right angle as C, and the sides are lowercase letters. In particular, here's what it's going to look like. Number 4. You have a right triangle, ABC. The right triangle, the right angle is C, and then you just call the other two angles angle A and angle B. So the capital letters are angles. The sides opposite the angles, those are the lowercase letters. This is the hypotenuse is lowercase c. Here's lowercase a, and here's lowercase b. Okay? Let's see. So that sets up the triangle. Let's read through the instructions. Suppose triangle ABC is a right triangle with sides A, B, and C. Find the unknown side length using the Pythagorean theorem. You see, we're told side A is 6 and side C is 7. So 7, 6. Find the unknown side using the Pythagorean theorem. I bet you that you could have figured out B without, if it hadn't told you, use the Pythagorean theorem. And then once you have all three sides labeled, it's going to be like this first problem we did. Once you know all three sides, find cosine, whatever, whichever angle it's asking you to use, sine, and so forth. So let's first of all take care of finding the unknown side using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So a is 6. Ooh, can y'all tell my b's from my 6's? And c is 7. Sometimes students say, well, just use a capital letter for b. No, you can't use a capital letter. That would be an angle. So let's see. We have 36 plus b squared is 49. Solve this for b by subtracting 36. And then take the principal square root of the positive square root. That's the square root of 13. So the unknown side length is square root of 13. Now we know all three sides, so we're going to start doing the SOHCAHTOA, but it's critical that you know which angle you're going to be using because that determines the adjacent and the opposite. We're told, oh yeah, this will work really good, just like that. We're told find sine B. So you're using angle B. So which one of these is the opposite and which one's the adjacent? C is the hypotenuse. That's why I draw the little arrow. There's the opposite. So sine B, opposite over hypotenuse. SOHCAHTOA. See? Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Let me see. Oh no, I'm running out of room now. Okay, that'll do. Cosine is adjacent over hypotenuse. The adjacent is 6 over hypotenuse 7. Tangent is opposite over adjacent. Square root of 13 over 6. And now we get to the three reciprocal functions. Do y'all remember which one's the reciprocal of secant? Which one of these am I going to flip? Well, secant is the reciprocal of cosine. So 7 over 6. Cosecant is the reciprocal of sine. So 7 over the square root of 13. If you feel the need to rationalize, okay, there will be some problems where it'll say, oh, if you don't rationalize, it's going to count it wrong, my math lab. And then there'll be others where it'll let you punch in 7 over the square root of 13 and say that's fine. And then cotangent's the reciprocal of tangent, 6 over the square root of 13. Rationalize to get a 6 square root of 13 all over 13. Am I out of room there? And this one, what did we do? We had to find the unknown side B. And then it's very much like the first problem we did. You now have the triangle all labeled. So go through the SOHCAHTOA stuff to find sine B. Now realize the answers would have been different if it had said sine A. Because then the opposite would have been over here. Okay. Now let's do this problem here. It says, it says solve the right triangle. When it says solve a triangle, that means you're going to find all the unknown sides and angles, everything that's not known. Now let's look at the triangle. Look at how it's labeled. it's triangle MNP. Okay, no reason it can't be MNP. It doesn't have to always be ABC. But notice capital letters are angles, lowercase letters are sides, and I think this 125 means 125 meters, okay? But it is side M, okay? So in this particular problem, we're given lowercase m, we're given angle N, and we know angle P. And the first thing it says to do is find angle M. Well, we can do that just using some knowledge from geometry. The three angles inside a triangle have to add up to give 180 degrees. So, if you know two of the angles, just go 180 minus 90 degrees minus 59.8 degrees. Well, 180 degrees minus 90 degrees is 90 degrees. Minus 59.8 is 30.2 degrees. So 30.2 degrees. That's angle M. Now it's going to take some thought. We've got to find side N and side P. This is two separate problems. First thing we'll do is find side N. So find lowercase n. Look at what we have. Looking at the triangle. I want to come up with a trig function that involves what we're looking for, side N, and then these two things that are known here. So let's look at the angle, 59.8. Using that angle, the 125, that's adjacent, and this side N, that's opposite. So I'm looking at the angle. The angle that we're given is what determines which trig function I'm using. I could write this as which trig function, sine, cosine, or tangent, involves adjacent and opposite. Well, tangent. Tangent, 59.8 degrees equals, tangent is opposite over adjacent, N over 125. Now we need to solve this thing for N by multiplying both sides by 125. So we're going to have to use a calculator to get the answer in a minute. We have 125 tangent 59.8 degrees equals N. So I looked at the angle that we had there. That's what how I decided between sine, cosine, or tangent. Looking at that, the N, and the side that we knew. Those are opposite and adjacent sides. So to punch this into your calculator, I'm going to punch that orange stuff into my calculator. Let's see, how do I do that? Oh, can y'all tell that's sort of hard? When you're punching stuff into your calculator, if you have a calculator like mine, and if you don't have a calculator like this one, this is the type of calculator I'll be using this semester, you've got to make sure that it's in degree mode. Okay? There are two angle measuring systems that we'll see, radian measure and degree measure. You need to make sure that degrees is black. If it isn't, you have to, like here, I just switched it into radian measure. But what we're using here are degrees. And if you're thinking, well, I don't know what a radian measure is, that's okay. We haven't defined them yet. We'll get to that eventually. but you do need to make sure you have it in degree mode. Say quit, and I know there's a bit of a glare. 125 tangent 59.8, close the parentheses, enter. So here's what we're getting for n. 214.7715. Let's see how they tell us to round it. Okay, they say round these to the nearest integer. So this 214.77, I'm going to round to 215. Okay, rounding to the nearest integer. So n 215. We still need to figure out p now. And I'll do that right here. To find p, we don't really need to use any trigonometry. We'll use some geometry. We have a right triangle, so that a squared plus b squared is c squared. Or in other words, in terms of mn and p, m squared plus n squared is p squared. So I'll write p squared equals 125 squared plus 215 squared. I'm using the Pythagorean theorem. If you want to think of it as a squared plus b squared is c squared. So I'm going to punch in the 125 squared plus 215 squared. 125 squared plus 215 squared. Enter. Oops. But that gives me p squared. If I'm going to find p, I need the square root of that. So second square root, second a and s. So 248.6966, rounding to the nearest integer, let's say 249. Okay. Any questions there? We are solving right triangles. That's what this is called, solving right triangles. We're finding all the unknown sides and all the unknown angles. Now, let's do another one of those. We'll do this problem number 7. It's the same type of problem, except the picture's not drawn for you. You got to draw it yourself. So that'll be a good practice problem for you. It's right out beside it. Let's draw triangle ABC. C is the 90-degree angle. So there's angle C. And then call the other two sides A and B. It doesn't matter which one you call A and which one you call B. So A is 21 degrees. Lowercase c, that would be the hypotenuse, is 17.3 feet. And the first thing they say to do is find angle B. Okay, we can do find angle B just using geometry. We don't need any trigonometry for that. Why? Well, the three angles inside a triangle should add together to give 180 degrees. So I'll go 180 degrees minus 90 degrees, then a minus 21 degrees. 180 minus 90 degrees is 90 degrees. Minus 21 degrees, is that going to be a 69 degrees? 180 degrees minus 90 degrees minus 21 degrees is 69 degrees. That's angle B. Okay? So 69 degrees. Now it wants us to find the length of side A, and then finally the length of side B. The last one you can do using the Pythagorean theorem. Now we're trying to find side A. So I'm going to look at the triangle. Now I'm going to label the side that we're looking for, side A. Now even though we found angle B to be 69 degrees, you've got to decide on an angle to use. And I'm going to use the angle that we were given. So I'm using this angle, this side we were given, and we're looking for this one. So those are the three things I'm looking at to try to decide which trig function do we need to use. Well, I'm going to circle this, that, and that. The angle is what you use to determine between, like the 17.3, that's the hypotenuse. So it's either going to be sine or cosine that we're using. But here, using this angle, is this side A opposite or is it adjacent? It is opposite. So, which trig function involves opposite and hypotenuse? Well, that's sine. So I'm going to say sine A is opposite. Oops, I didn't want me to get out of here. That's fine. Sine A is opposite over hypotenuse. Oops, you know what? I should have replaced the capital A with 21 degrees. It's opposite over 17.3. So to solve this for lowercase a, I'd multiply both sides by 17.3. So here's what I'm after. 17.3 sine 21 degrees equals A. And, if I clear out all of that, let's see what we'll get. If I start 17.3 sine 21 degrees. So A is 6.19976. How are we told to round this? Round to the nearest tenth as needed. So what would y'all call that? 6.2? 6.2. So 69, 6.2 feet. This is 6.2. So now the only thing left to do is find what? B. And we can find side B just by using the Pythagorean theorem now. We know A squared plus B squared is C squared. So A was 6.2 squared plus, we're trying to find B squared. C is 17.3 squared. So I'm going to subtract that 6.2 squared, and then I'll take a square root. So we have 17.3 squared minus 6.2 squared, 260.85, second square root, second A and S pulls up that previous answer. So B is 16.15085 ... And how are we rounding these all to the nearest tenth? So B would be 16.2. Okay. Any questions there? This is called solving a right triangle, and I'm sort of, let me see there. Oh, good, now it obvious. Okay? Ooh. Maybe you have time to do one more of these. It's real important that you get the hang of which trig function do you use. Let's see. Looking at all of this. Don't want to use. Oh yeah, we've already seen this problem 8. Let's go ahead and do problem 8. It's been showing down there. Oh, okay. Same type of problem. We have a right triangle. ABC. I'll put A there and B there for no reason. B is 73 degrees. So, and side B is 120 inches. So, let's see. To find angle A, that's going to be pretty easy, right? To find angle A, that's 180 degrees minus the 90 degrees, which is 90 degrees, minus 73 degrees. 180 minus 90 is 90. 90 minus 73, is that 17? So there's angle A. Now it says find side A. Let me see if I can be consistent with my colors. I'm going to find side A in green. Okay. Well, that would be this side right here. So I'm only going to look at the stuff that's labeled. Even though we figured out angle A, I've decided to use the one that was given to me, 73 degrees. So since I made the decision to use this angle, let's see, what are these two sides? Well, neither one of them is the hypotenuse. And so it's not going to be sine or cosine, it's going to be tangent. You would say tangent 73 degrees. Tangent is opposite over adjacent. Tangent 73 degrees is opposite over adjacent. And to solve this for A, well, it looks sort of bad because of the A's in the bottom, but it isn't really. Multiply both sides by A, and then divide both sides by tangent 73 degrees. So here's what I'm going to be punching in. 120 divided by tangent 73 degrees. So I'll get my little calculator, which you probably can't see with the glare, and put on 120 divided by tangent 73. Ooh, all I can see. I should have, what I should have done, let me clear out all of that, and we'll do it again. 120 divided by tangent 73 degrees. And so we're getting for A 36.68768. Now, how are we told to round this side A to the nearest tenth? 36.7 inches. Okay, so angle A is 17 degrees. Side A is 36.7 inches. Almost through. The length of side C, let's find C. Well, since we already know that A is 36.7 and B is 120, just use the Pythagorean theorem. C squared is A squared plus B squared. C squared is 36.7 squared plus 120 squared. So add those together. 36.7 squared plus 120 squared. Hit enter. And then take the square root of that number. Second square root, second A&S just pulls up the 15,746. So C is 125.4866128. Round to the nearest tenth, so 125.5. When solving problems, you should always be asking yourself, is your answer sensible? The longest side should be opposite the biggest angle. So is the hypotenuse the biggest side? Yes. Okay. The shortest side should be opposite the smallest angle. Well, angle A is only 17 degrees, so it's certainly the shortest angle, the smallest angle. And it's the shortest side is opposite it. Okay? So this is solving right triangle, so hopefully that's enough to get you working on it. And we're going to see some nice applications. We'll continue working with these right triangles the next time. We'll see some applications to navigation and so forth for these. So work on these, and well, right now it's very cold outside, so I'll say stay warm, but who knows when you'll be listening to it. Maybe it'll be in the middle of a heat wave or something. But okay, bye-bye.